This is Pre-Calc, section 6.8, partial fractions. This can be a pretty complicated section and it will take several videos to get through the material. The technique of partial fraction decomposition is used in calculus and beyond, so it's an important skill for us in pre-calculus. The idea of partial fraction decomposition is that we're working backwards. We're trying to figure out the fractions that were added together to get a particular sum. So take a look at this fraction right here. This was our answer. We know that there were two fractions that were added together to get this fraction. We want to figure out what's what. So here's our steps. Number one, you check to see if the numerator degree is greater than or equal to the denominator degree. If so, we must start with long division. Well, that's not the case here. The degree in the numerator is 1, the degree in the denominator is 2, so the numerator is not greater than or equal to the denominator degree. Secondly, you want to factor the denominator. So this is just simple factoring, and this factors as x minus 5 times x plus 1. Now the factors of the denominator become the individual denominators. See how I wrote this up here? The two fractions got added together to give us this. Well, one denominator is x minus 5. The other denominator is x plus 1. So we're partway there. We know what the denominators were. But now we have to figure out what goes in the numerator. So if the denominator factors are linear factors, now what that means is x minus 5 is linear because there is no exponent on here. X squared, x cubed, it's plain old x minus 5. You could think about linear being y equals mx plus b, where x minus 5 is our mx plus b. So these are linear factors. If these are linear factors, you let each numerator equal some real number. And what we put here is a constant a and a constant b. So when I say it equals some real number, you can't just make up a real number and put it there. A and b are standing in for the real numbers that would be in the numerators. So if the factors are quadratic, we'll see that in another problem a little bit later on. So this is what we're looking at, is this equation right there. And I'm going to pull this up because this looks a little bit neater. So that's what I have right there. This is a rational equation. To solve a rational equation, we must clear out the denominators. The common denominator is x minus 5 times x plus 1, and we need to multiply on both sides by that common denominator. So this skill right here is a basic Algebra 1 or Algebra 2 skill. Once we've gotten to that step, it's a matter of using our plain old algebra skills. Well, x minus 5, x plus 1 is going to cancel out right here, and we get 3x minus 8. So there's really no work for us to do on the left side. On the right side, x minus 5 is going to cancel with this x minus 5. I don't want to cross it out because I'm going to need it in a minute. So pretend this is crossed out, and it's canceling with this x minus 5. What's left is a times x plus 1. I do not want to distribute that. Now for this one, I will cancel this out. X plus 1 cancels with this. What's left is b times x minus 5. I do not want to distribute. So that's where I am right now. I'm going to have to solve this equation for a and b. To solve this equation for a and b, I need to remember that this equation is valid for any value of x, which means I can pick any value of x I want. So I want to say let x equal 5. Now the reason I'd like to pick 5 is when I put 5 in here, this goes away. So right away I've gotten rid of one of my variables. So if I put 5 in for each of these x's, I'm looking at 3 times 5 is 15, minus 8 is 7. Over on here, 5 plus 1 is 6, a. And we already said putting 5 over here cancels that out. So I have one variable, a, that I can solve for. So a is 7, 6. I need to repeat that process, but this time I want to let x equal negative 1. Negative 1 in here will make the a part go away. Put negative 1 here. 3 times negative 1 is negative 3. Minus 8 is negative 11. Put negative 1 here. Negative 1 minus 5 is negative 6 times b. Divide both sides by negative 6, and I get 11, 6 for b. So pretty easily there we have found our coefficients of a and b. So we fill in 7 over 6 here for a and 11 over 6 here for b. But what MATLAB wants us to do is to clean this up a little bit. It wants me to keep a 7 up here, drop the 6 down into the denominator. Same thing with this fraction. Keep the 11 here, drop the 6 down into the denominator. Now that's not just magic of drop it down to the denominator. Think about complex fractions. This is like 7 over 6 over x minus 5 over 1. When you have a fraction over a fraction, the way to simplify that is to keep the top what it is and flip the bottom upside down and multiply. And that shows you why the 6 ends up in the bottom. But you don't have to go through all these steps. You just can grab hold of this, drag it down here, and there's your answer. All right, here's another one. This time, again, we're looking to see if the numerator degree is greater than or equal to the denominator degree. That is not the case. We do not have to worry about long division. That's going to happen later on. The denominator is already factored. That's pretty nice. And it has 3 different factors, which means I need to set up 3 separate fractions. And each of these denominators will be x minus 1, x plus 1, and x plus 4. They are all linear factors. They will all get an a, b, a c. There's an equation written a little bit more neatly. I'm going to multiply both sides by the common denominator, which is x minus 1 times x plus 1 times x plus 4. What's going to happen over here is all of that denominator cancels with all of that denominator, and we just get a nice simple 4x plus 9 over here. Now over here, so you don't have to do all this canceling in your head, this is what I'm going to do. If I have an x minus 1 here, it will cancel with that x minus 1. So I'm just going to cover that up. And what I need to write down then is I will have a times x plus 1 times x plus 4 plus I'll have b times something, so let's move this out of the way and see what's canceling. This time x plus 1 cancels with x plus 1. Get rid of that, the x plus 1 is gone, and I have b times x minus 1 times x plus 4. And then the third one, I see I have an x plus 4 is going to cancel with that x plus 4, so x plus 4 is gone, and this is c times x minus 1 times x plus 1. It looks pretty ugly, but it's not bad because we are not going to FOIL, we are not going to distribute. We are going to do the same thing we did on the last problem, and that is we're going to substitute in some values for x and get some values for a, b, and c. So over on this page, I've got it written a little more neatly. So this equation is valid for any value of x. I'd like to let x equal 1, and the reason I would like to let x equal 1 is because if I put 1 here, all of this is going to go away, and if I put 1 here, all of this is going to go away. So I have to put 1 in here, and 1 in here, and here. So 4 times 1 is 4, plus 9 is 13. Then 1 plus 1 is 2, 1 plus 4 is 5, 2 times 5 is 10, a. So by choosing wisely, I get rid of the a and I get rid of the b and the c, and I now have a value for a. A is 13/10. I will repeat the procedure, but this time I want to let x equal -1. If you put -1 in here, -1 plus 1 is 0. 0 times this makes all of this go away. I put -1 in right here. That's going to make a 0 times all of this stays 0. So really all I've got to look at is this. So put -1 in for this x, and this x. 4 times -1 is -4, plus 9 is 5. -1 minus 1 is -2. -1 plus 4 is 3. -2 times 3 is -6b. Divide both sides by -6, and b is -5/6. Repeat the procedure this time and let x equal -4. Or -4 right here is going to make this become 0, which makes all of that go away. -4 right here makes that become 0, which makes all of that go away. So that's all I have to really substitute in on. X is -4, -4, -4. So 4 times -4 is -16, plus 9 is -7, equals c times -4 minus 1 is -5, -4 plus 1 is -3, that's 15. I should have written 15c, but I've got c times 15. Either way, divide by 15, and c is -7/15. Those are your 3 values for a, b, and c that get substituted back to these fractions. A is 13/10, b is -5/6, and c is -7/15. But we need to clean that up to where we have 13 over 10 times x minus 1 minus 5 over 6 times x plus 1 minus 7 over 15 times x plus 4. And that is the partial fraction decomposition for that problem right there. If you took the time to check and actually got common denominators, added all of this up and simplify, you would end up with that fraction.